Okay, solving a trigonometric equation. This one involves cosecant of theta is equal to -2. And take note that our thetas, our solutions here, we want them to be between 0 and 4 pi. So different than 0 and 2 pi that we see sometimes. So as we get going, I notice with this cosecant, I am not as familiar with my trigonometric ratios for cosecant. So I would probably go ahead and rewrite this in terms of sine. I know a reciprocal relationship between cosecant and sine. So I know if cosecant is -2/1, then that also equivalently means that sine of theta has to equal the reciprocal here. So I can say -1/2. I'm simply taking this fraction, flipping it upside down, inverting numerator and denominator. Now that it's in terms of sine, this is a little bit easier to work with. So 1/2 is one of these common ratios that shows up a whole lot when we're dealing with sine, cosine along the way. And I know that theta, if I plugged in a pi/6 into sine, would produce a +1/2. Now I'm representing this with theta bar for right now because I'm going to use the same angle, but use it as a reference angle and place it into the appropriate quadrants that are going to give me a negative result coming out of sine. So how do we remember where is sine going to be negative? Well, I like using the phrase all students take calculus because this just helps me remember where everything, all of our trigonometric ratios are going to be positive in the first quadrant. Only sine is going to be positive in the second quadrant, tangent in the third, and cosine in the fourth. So if only tangent's positive in the third, that means that sine and cosine are both going to be negative. If only cosine's positive in the fourth quadrant, then sine and tangent are both going to be negative. So we are looking for sine to be negative. So I'm going to find one angle in the third quadrant and one angle in the fourth quadrant initially. So the angle in the third quadrant, remember we already picked out what I'm going to use as a reference angle here, the pi/6. We're going to place that in the third quadrant. And then we want to do a calculation to figure out which angle would wrap around from 0 degrees all the way into the third quadrant that would have pi/6 as a reference angle. So the calculation that we want to do to find that quadrant 3 angle is you want to say, well, it's pi to go this far around, halfway around the circle, and then it's beyond that pi/6. So this calculation I would do is saying, well, pi plus pi/6. Or we can visualize that as 6 pi/6 is equivalent to the pi plus pi/6 would give us 7 pi/6. That's an angle in the third quadrant that we just located. So if I plug 7 pi/6 in for this theta, that's going to produce a -1/2. There is a little bit more to this, so don't go away just yet. Remember, we're going between 0 and 4 pi. All right, next one I would locate is in the fourth quadrant where only cosine is going to produce a positive. So again, I'm going to place what we just located as our reference angle, the pi/6, into the fourth quadrant. Remember, it's 2 pi to go all the way around the circle. I'm trying to locate the angle that if I wrap around into the fourth quadrant is going to have pi/6 as a reference angle. So this calculation for our quadrant 4 angle, theta is going to be given by 2 pi minus the pi/6. 2 pi would be all the way around. You take away this pi/6, it's going to go around for this red angle that lands in the fourth quadrant. I would probably rewrite this as 12 pi/6, so I get that common denominator. Minus pi/6 is going to give us 11 pi/6 for our value for theta. However, we do want to be a little bit careful. All right, these are going to be two of our solutions, one in quadrant 3 and one in quadrant 4. But remember that theta is between 0 and 4 pi. Now, if we weren't specified any of these regions and asked simply to give all the solutions, what you want to do at the very end of our solutions is add 2k pi or 2 pi times k to the end. This can represent all of our solutions without regard to a given range for our theta. All right, it's always the period for whatever trigonometric function we're dealing with. So sine in this case is 2 pi multiplied by k, which is going to be some integer. Basically, we're finding coterminal angles like wrapping around an extra time around the circle. Okay, so this is how you would represent every single solution would be like this, but in our case, we are limited from 0 to 4 pi. So what I'm going to do is do these calculations real quickly. The first one would be when k is equal to 0. That's going to be pretty easy, that all we're going to do is plug in a 0 for our k, and this adding 2k pi goes away. So if k was 0, we would get 7 pi over 6 and 11 pi over 6. The two that we basically came up with without doing any extra work. But what happens if k is equal to 1? So if k is equal to 1, we have 7 pi over 6 plus 2 times 1 times pi, or 2 pi. I'll go ahead and put a times 1 in here as well. But that calculation is going to be 7 pi over 6 plus 12 pi over 6, right? Common denominator again, just rewriting the 2 from 2 pi, so it's 12 over 6. That's going to give us the solution 19 pi over 6, which is still 19 divided by 6 is smaller than 4. All right, so these two solutions, we got that one, and then we also want to plug in a 1 over here. So last one, as we plug in a 1 for k, we can say 11 pi over 6 plus 2 pi, or again, that's 11 pi over 6 plus 12 pi over 6, written with a common denominator, which is going to be 23 pi over 6, which is going to be a fourth solution between 0 and 4 pi. And 23 divided by 6 is just slightly smaller than 4, so it still fits in the appropriate range here. So those are all of our solutions: 7 pi over 6, 11 pi over 6, 19 pi over 6, and 23 pi over 6 for our given range between 0 and 4 pi for our theta. If you are not given that specific range and asked to represent all of the possible solutions or all of the solutions, it would be these two boxes down below here with the plus 2k pi attached to the ends. All right, I hope this helps out on solving down trigonometric equations. Good luck.